So good evening and a very warm welcome to the Oxford Martin School and our continuing seminar series on climate change and how to stop it. Thanks to you all for coming. This is the third in the series, which will continue through this term and the next. And we're absolutely delighted to have Professor Myles and Nick Eyre here talking on what science and the IPCC report have to say. Professor Myles, of course, is a member of the Intergovernmental Panel on Climate Change. He's been a lead author on one of the groups and has been highly engaged in it over many, many years, so intimately connected with that. He's the Professor of Geosystem Science in Oxford, and he's also the co-director of the Oxford Martin Programme on Resource Stewardship, which is one of the cluster research programs in the Oxford Martin School. I'm the director of the school, and we're delighted that Myles and his team are working in that area along with the other co-directors. Nick Eyre is a Jackson Senior Research Fellow in Energy at the ECI Environmental Change Institute. He leads the ECI program on low carbon futures, and he's also co-director of the university's collaboration across different universities on the UK Energy Research Centre, amongst their many other attributes. Myles, I understand you're going to begin.
Thank you. I've got a throat mic, so you've got to put a better hand to that, or it'll feedback or something bad will happen. Good, okay, well, thank you very much. Thanks for the intro. As Ian said, I've been involved in the IPCC since I was a fairly freshly minted postdoc in the late 90s. I think my views of the IPCC have gone from sort of naive enthusiasm to disillusionment and ended up as sort of resigned acceptance that it's the way it is. And I hope the discussion here will be about the IPCC as much as it's about the science, because I think it's a really interesting model of how we try and translate science into policy, and how we, as a scientific community, go about informing the policy process. And while following our brief, I think Nick and I will talk a bit about sort of what the key findings are from the IPCC fifth assessment. I suspect most of you have heard them all, at least the sort of the headline level findings already. And so I think what I'd like to talk more about is sort of how the IPCC process works, and not so much at the detailed, boring bureaucratic level, but at the sort of philosophical level, and how it's informing the policy process, because it's an interesting area. These are the sort of key headline conclusions of the fifth assessment after many hundreds, well over 1,000 authors and lots of air miles and so forth reached these sort of headline conclusions. And some of us might look at this and say, well, okay, did we really need all that effort to say this again? Actually, the first two are the ones I might have had some involvement in. And those are the ones where I think a lot of people would sort of roll their eyes a bit and say, do we really need to say this again? The third one I think is more, potentially more eyebrow raising, and Nick will be talking more about that, about how it is still possible to limit climate change in the context of a more prosperous and sustainable future. But I'm going to be focusing on the science issue, the first and second bullets, if you like, the working group 1, working group 2 aspects of climate change. I'm also going to be, by the way, I couldn't resist showing you some stuff of my own, so I'm going to also try and connect up some of what the IPCC says with what you heard about from Tim Palmer last week. So there's some fresh stuff I did at lunchtime. There's always got to be something like that in a talk. So here we are. This is the sort of headline conclusion of the attribution analysis, which I was involved in the fifth assessment. It's extremely likely, in the technical jargon, that means 95% confidence that we're the dominant cause of warming since the mid-20th century. I was had the dubious privilege of being the presenter's friend on the BBC while they were running the press conference. So I'd explained to the presenter how it all worked and what these statements all meant. Just as the red light came on and we knew all the cameras were live, he turns around to me and says, right, Professor Allen, so scientists are 95% confident that most of the warming is due to human influence. What do the other 5% of scientists think? So you can see immediately the challenge we face communicating this stuff, and it raises immediately a sort of fundamental question about what the IPCC is for. The IPCC was originally set up to advise governments, and I don't think most of the civil servants who use IPCC reports to advise their ministers what their positions should be in the intergovernmental negotiations, I don't think most of those would be confused about what 95% confidence means. Most of them have some sort of technical background. That's not really an issue. But obviously, for the presenter was doing his job very well, because I would imagine probably more than 95% of the television audience wouldn't have a clue what the difference was between 95% confident and 95% of scientists being confident. There is a question here whether the IPCC really can fill this role of informing everybody, not just the policy makers that it was originally set up to inform, about climate change, because this is a relatively new role for IPCC. When I was involved in the one I was most involved in actually was the third assessment report. And that one was it was very technical, it was delivered to government, it was reported on page 3 of The Guardian, and that was about it. There was really, it was a very different operation. Whereas in the fourth assessment report, as you know, was the one which really hit the headlines and put the IPCC into the public spotlight. Okay, so we are seeing changes in climate, we're projected to see more changes in the future, and the impacts, this is the sort of key new finding, if you like, in the latest IPCC assessment, is that we are seeing impacts already underway. On all the continents, all the inhabited continents of the world, we are seeing impacts of climate change already emerging and affecting both rich and poor countries. These are the sort of headline statements that were pulled out after the Copenhagen meeting. I wanted to highlight this one because this finding, some of the changes in extreme weather and climate events observed since about 1950 have been linked to human influence. This is very much stuff we do in Oxford, actually. This is one of the main centres in the world for this science of linking extreme weather events and climate change. It's one of the developments that has clearly percolated up through the IPCC process and is recognised as something which is very important for the policy community. What's more worrying, of course, this was the slide that Pachauri used, the chair of the IPCC used to present this to the government delegates in Lima, we certainly have no conclusive studies, to my knowledge, that link hurricanes, for example, to human influence on climate. And it's pretty. So I mean, it's as soon as you put up a slide like this, it's like, oh yeah, but you can't really say that, can you? But anyway, it's clearly. I'd like to highlight it because it's something Oxford's in the middle of. And it's something which is clearly recognised as important. One of the things that, to illustrate how sort of technical the IPCC process has become, you really have to be quite an enthusiast to recognise the importance of what the IPCC doesn't say, as well as what it does say. Working Group 2 of the IPCC on impacts did a lot of work identifying all over the world, all these little symbols mean an impact on some particular system, either a human system, a natural system, or managed system. And these are all the impacts of observed climate changes that have been identified in the literature. But unless you're a real enthusiast, you don't realise that observed climate changes, so here's the European ones, you can see we've seen impacts on marine systems, forest fires, human systems, and so on. Observed changes here does not necessarily mean anthropogenic changes. It just means the changes that have happened over the past few decades. And although that's said, clearly, in the fine print, well, not just in the fine print, in the full print of the report, I do wonder how many of the public reading the report actually get that. And the reason, of course, is that the support in the literature for a global assessment of the impacts of human influence on climate, on actual systems that matter to people like marine systems, it just isn't there. That literature doesn't exist yet. We haven't yet done the studies to link human influence on climate with specific observed impacts. So this is, Working Group 2 were doing that's the working group on impacts were doing what they could do, but there's still a big gap in the IPCC process and one which I certainly would hope we manage to fill before the next assessment, making the connection between human influence, greenhouse gas emissions at the one end, and actual impacts on things which matter at the other. The other highlight they pulled out was the potential risks to food production in the future, and since we've got a lot of work going on the future of food, both in the Martin School and also in ECI and other parts of the university, I thought I'd highlight that as one of the key findings of the IPCC report. But the main one I want to focus on, of course, is the figure which I was most heavily involved in, which I of course think, I would say this, wouldn't I, but I of course think is one of the most important, if not the most important findings of the latest IPCC assessment, which is that it's cumulative carbon dioxide emissions that determine global mean surface temperature, certainly by the late 21st century and beyond. And this is a very simple figure which was highlighted in both the summary for policymakers of the IPCC, the Working Group 1 report on the science, but also the synthesis report bringing together the science impacts and policy implications, showing a nice, simple, straight line relationship between the total amount of carbon we dump in the atmosphere and the total warming we get. And again, you could say, well, why has it taken us 20 years and several IPCC cycles to plot something quite this simple? Well, you know, you've got to sometimes work through things in lots of different ways to come up with it. But it does have very simple, practical policy implications. That, by the way, is the contribution to the warming due to CO2, and other factors are adding on to that CO2-induced warming. That's the range of uncertainty in the CO2-induced warming. The policy implications of this, of course, are nicely illustrated by this schematic figure. Well, it's not a schematic figure, it's an accurate representation of the state of the studies from the synthesis report, which draws together those burning embers diagrams which shows the risks to various different aspects of the climate system, risks to unique and threatened systems already emerging even at the warming levels we're seeing now. To pick another example, the risk of global aggregate impacts or large-scale singular events only increasing to high levels when we reach over 3 degrees of warming. And that allows, the idea of this is it allows, that's the information coming out of Working Group 2 on impacts. The policymaker looks at this as allowed to look at this and say, right, we want to stay below 2 degrees, for example, in order to minimize the risks to these various different systems. You can read across to find out how much cumulative carbon dioxide emissions that implies, so you're sort of somewhere there. If you want to keep a reasonably good chance of staying below 2 degrees, that implies that sort of budget, which in turn implies those kind of emission reductions by 2050. So you can see that in order to meet that overall carbon budget, we have to reduce carbon dioxide emissions by somewhere between 25 and 55% or 60% by 2050. So it's a way of placing the impacts into the overall cumulative carbon budget and then expressing what that means in terms of immediate emission trends. So that's why this carbon budget is a very powerful policy tool, a powerful way of framing the climate challenge. So those are the sort of key findings, and I thought I'd now just sort of give you a few things to think about in the IPCC, about the IPCC process, about the way it works, and in particular use this cumulative carbon example as an illustration of how the IPCC process works and how these reports and summaries get developed. Before we went to Stockholm in September 2013, that was the final plenary of the IPCC Working Group 1 working group, on the physical science of climate change. This was what we had in the summary as a statement about the cumulative budget, limiting warming caused by anthropogenic CO2 emissions alone to likely less than 2 degrees relative to pre-industrial will require cumulative CO2 emissions from all anthropogenic sources to stay below about 1,000 petagrams of carbon from the beginning, since the beginning of the industrial era. I was pretty happy with those words, apart from the comma, which I was convinced was ungrammatical, but the German authors insisted on putting that comma back in, so I gave up on that one. But it, you know, and the petagrams of carbon was a bit of a weird unit, but everybody insisted it was SI, so fair enough. So that was what we went into. So at the end of each IPCC cycle, there's a meeting in which government delegates sit around in a big room, and there's, sorry, some of you probably know this very well, but just for the benefit of those that don't, every country is represented or can be represented. Most of them show up. They're there, there's simultaneous translation going on, it's all very formal, there's a panel at the front and somebody with a hammer, and it's all quite intimidating. And they go through the text of the summary, sentence by sentence, and discuss whether it's, clear, whether it's liable to be misunderstood in Arabic, for example, and whether it's an accurate representation of what the scientists are trying to say. And it's, the idea of this is that it's perfectly possible for scientists to sit down and write a report or an assessment and say things which are completely misunderstood. And there's plenty of examples of how this works, say things which are completely misunderstood by non-scientists as soon as they're released. So the idea of this is to make sure that both sides, this is a process of advice to governments, to make sure that on both sides everything's understood, and the final text is clear and unambiguous for the users. And it's important to stress that everybody has a veto in this process. Every country in the room can put their flag up and say, we don't like this sentence, we want it cut out, or we want it changed. And the process does not continue until all countries have agreed, yeah, okay, that sentence will do, the gavel goes down and they move on. So as you might imagine, what tends to happen is an awful lot of time is spent on early sentences, and then everybody starts working all night. In the Stockholm meeting, I think they were working all night just for the last night. In the plenary report meeting, they actually started the all-night sessions on the Wednesday, and we actually had 3 all-night sessions in succession, by the end of which I was virtually hallucinating. It was very difficult to stay focused. But some people, like Benito here, are kind of used to this and seem to be able to do it all the time. But anyway, I certainly can't. So this is where, so this bullet was actually fairly late in the draft. It came fairly towards the end of the draft, so it came up for discussion. About 2 o'clock on the Friday morning. Everything had to be finished by the press conference scheduled for 8 o'clock on the Friday morning. So it was, tempers were running a bit high by this stage. And this is what happened. So this is what came out. As you can see, the comma's still there. And in fact, the content of the bullet going in, probability greater than 66% and 1,000 gigatons of carbon. If you know your units, that's the same as petagrams of carbon. So that information has survived, but a whole lot of more information has been shoved in. And the concern, the concern was from governments that if they didn't give all this information, the original statement was overly policy prescriptive. And I wanted to sort of talk now about sort of what this, because it was drawing attention to one budget, one level of likelihood that was, and also CO2-induced warming alone. Have I got about sort of 5 minutes? I don't know who's keeping time, but okay. Okay, good. So I wanted to talk to you about what was going on here and why these different. So what we have here are, in addition to the original bit of information that if you want to have likely less than 2 degrees, you need to stick to 1,000. We've got information like, for example, if you want to be unlikely to stay below 2 degrees, you've got a budget of about 1,500. And you might say, well, why should anybody want to know that? Okay, and I'm going to tell you why, actually. It's very interesting, because I've got an explanation of why people would want to know that, and I'm going to tell you about it now. By the way, this is how it was simplified a bit for the synthesis report meeting, but so why to begin with are we focusing on 2 in 3 odds of temperature less than 2 degrees? So this is a sort of, it is a schematic illustration of the kind of distribution that's at least consistent. Well, this distribution certainly is consistent with the IPCC's likely statement. That's the warming in response to 1 trillion tons in the horizontal. Don't worry about the vertical axis for now, but it's a distribution of uncertainty. Okay, and so we're saying the IPCC is drawing attention to the trillion tons because that gives you a 2 in 3 chance. In other words, 2/3 of that curve is to the left of 2 degrees. That's what it means. But why 2/3? Okay, why not say 95% confidence? In fact, there's quite a lot of grumbling in both in Stockholm and also in Copenhagen in the synthesis report meeting, is why are we taking a 1 in 3 chance? I mean, people are saying, oh, you wouldn't get on an airplane if there was a 1 in 3 chance of the airplane crashing and so on. So I'm going to tell you why, actually, and I realized why watching Tim Palmer last week. I'm very sorry, Tim's not here, is he? He's going to miss out on. So this is actually a live application of Tim's ideas from last week. This is a typical estimate of how damages go up with global temperature in an integrated assessment model. So notice that as you go to higher temperatures, we see damages increasing more rapidly. And most of these assessments assume that this is a roughly quadratic relationship. So it goes up roughly like the square of the increase in temperature. And if we ask ourselves, well, what then is the effective warming for corresponding to this budget? It's, ta-da, 2 degrees. Because of the uncertainty, if you set your budget to be likely less than 2 degrees, it actually means you're aiming for an effective warming, in Tim Palmer's probability-weighted sense, of 2 degrees. So it sort of makes sense. Indeed, if we had a very steep increase in damages, then the effective warming would be much higher than 2 degrees. In that case, you would probably want to say, we probably should have drawn attention to the budget which gave us very likely less than 2 degrees, or extremely likely less than 2 degrees, if we'd have thought that that was the shape of the damage exponent. But actually, most people think, no, damages don't go up precipitately as soon as you cross 2 degrees, but they go up faster as the warmer it gets. So that's a reasonable estimate. By the way, of course, if we assume that damages just went up linearly, then this would have been a rather a silly percentile to have chosen in the distribution, because then the effective warming. So there's a sense here in which Tim Palmer is showing that the IPCC process is vaguely rational, which I suppose is interesting. Well, I suppose it would be even more interesting if he was showing it was irrational. But it's nice how these things do link up, and it does make sense. But then, of course, it raises the question, and I'm going to wrap up in a couple of minutes, raises the question of why we were mentioning these budgets for odds of warming greater than 2 degrees, 2 in 3 odds greater than 2 degrees. Why were we talking about, in all those extra bits which are added to that bullet by the insistence of various governments, why were they relevant at all? And just thinking about this, I realized, of course, there's another convex function that other people worry about. A lot of people think about how the impacts of climate change go up as temperatures rise. But there are people in the room in these final plenaries who are very more preoccupied, perhaps, by this function, which is the cost. And this, I made this function up, but I'm just illustrating to you the implications of. But I suspect it will be convex. I don't know much else about it. This is a schematic of the cost of mitigation as a function of cumulative emissions. So if we go for a very high level of cumulative emissions, in other words, we just go for what we would have emitted anyway, there's no cost of mitigation right out here. Okay? If we try and reduce emissions, we're at 500 billion tons already, so if the cost of mitigation is going to zoom up through the roof as we head down to lower cumulative budgets. So that means, of course, if you're aiming for a carbon budget of 1 trillion tons, taking policies to aim for 1 trillion tons, you're actually going to be aiming for an effective carbon budget weighted by the probability of what carbon budget your policy actually gives you, much lower than that. So the key thing is which sort of set of odds you want to focus on depend on whether you're preoccupied about the impacts on the one hand or the costs of mitigation on the other. Now there's a sort of unwritten rule, it seems to me, in these meetings, and nobody wants to say we're more concerned about the potential cost of mitigation on our industries than we are about the impacts on our grandchildren. But it's a legitimate thing to be concerned about, and that needs to be balanced in these discussions, and that's why it needs to be. We have this process to make sure that the authors who are perhaps preoccupied with the impacts and the physical science of climate change, that needs to be balanced against the concerns of governments looking at their exposure to costs of mitigation. So I'm just going to wrap up giving you some points to think about in the IPCC process. you know, one of the things, there's two things I don't like about it, but I welcome ideas from this room about how this could be resolved. It's quite confrontational. It's sort of set up to test every sentence. You know, each sentence is argued over and so on. And to some extent that pushes the scientific community to some extent into taking sides on issues. Not always the same side, it should be stressed. In my experience of these final plenary meetings, that you're as often arguing with governments who want to, you know, as it were, make the language greener, as you are arguing with governments who want to make it less green. So there's definitely tension in both directions. But the fact that it's sort of set up almost as this sort of adversarial process to test each statement, although it's a very effective way of testing statements and pulling out their perhaps unspoken or subconscious assumptions, it does rather push scientists onto the sort of taking sides point. The other danger is the fact that these tremendously fat volumes that come out of this are misunderstood often as somehow having some kind of special significance, almost biblical infallibility, which is really daft and is the reason a lot of the sort of sillier criticisms of the IPCC which come out, because on the one hand people sort of put it up as a Bible that people have to follow, and then on the other hand, then you then have another team trying desperately to find small mistakes in it in order to prove that the Bible's not infallible. And so, you know, that I think is a very unhealthy picture of the way science works, and it does worry me about whether the IPCC process is somehow giving the public at large a misleading impression of how science actually works. The last question is a really sort of, I mean, perhaps it's not a personal one for me because I've been involved in this process for so long, I'm unlikely to be involved in it again. But it is a concern that as these reports get ever fatter and they're asked to address ever more detailed questions about climate change, there is the real concern about whether this is just this whole process might collapse under its own weight. Just because of the burden it places on the scientific community, asking vast numbers of very detailed questions, because it's obviously very convenient for governments to make sure those questions get answered by the IPCC process. So these are questions I'm hoping we'll get back to in the panel discussion, but at this point I'll hand over to Nick to talk about the findings of the IPCC Working Group 3 on the mitigation, which, as I said at the beginning, that was the area where I think the really exciting stuff happened in the latest IPCC cycle. Thank you.
Straight on. Thanks, Myles. Thank you, Ian. Hope this follows straight on. No, it doesn't.
Keep going.
No. Okay. Must be on here somewhere else. There we go. Thank you. So as Myles said, I'm going to be talking about Working Group 3, the mitigation bit of the IPCC, and hopefully some of the implications for Paris. I'm not going to try and tell negotiators what they ought to do, but some of the things they might want to think about. So I'm going to do two things. One, I'm going to give you a very edited highlights of Working Group 3 using the official IPCC presentation, very edited down. And then a more personal view on some of the science policy interface issues in the IPCC and what I think the two together mean for the Paris negotiations. So this is the official presentation. You can see my role in it was a humble lead author on Chapter 9, which is the chapter on buildings, and I'll say something about the way the IPCC divides its work up quite neatly in that way, which I think can be quite unhelpful. This is one of the major and I think unchallenged findings of Working Group 3. Myles might be talking about greenhouse gas emissions going down in future, but they certainly aren't at the moment, they're going up. And worse than that, whilst they've gone up about 1.3% per decade, up to 2000. That increased in the last decade up to 2010 to over 2% a year, so that total greenhouse gas emissions are now close to 50 gigatons, with a relatively low uncertainty by IPCC standards. It's one of the things we actually know quite well. The bulk of those emissions over 30 come from essentially from energy use, from CO2 emissions from fossil fuel and industrial processes, largely fossil fuel burning. So that's the dominant cause and therefore the dominant focus of attention for the mitigation report, but not the only one. This is a chart that didn't make it into the summary of the Working Group 3 report because it talks about the roles of different countries, and that's an interesting observation, but it is still true. And this looks at emissions in different categories of country by income, per capita income, which is a World Bank classification, and how they've changed from 1970. Quite startlingly, actually, the emissions of the lowest income countries have hardly grown at all in that period, and virtually none of them are from energy. The emissions of the highest income countries have grown considerably, but not hugely, from 14 gigatons to nearer 19. The biggest growth in emissions has been in the middle income countries, those countries which have industrialised rapidly since 1970, the BRIC countries, other Asian countries, where emissions have grown by about a factor of 3 over that period. And it was simply to obfuscate that made some countries object to it being in the summary report. It is worth pointing out that whilst upper middle income countries emissions are in total almost as high now as the high income countries, their per capita emissions are still, of course, far lower, and therefore the current as well as the historical responsibility is still predominantly with the high income countries, which are largely those in the OECD. This chart is another way of understanding the drivers of emissions. The white lozenges are the changes in global carbon emissions in each of those 4 decades. So we used to be trotting along steadily at increasing emissions at 4 gigatons per decade, and in the last decade we raised that to 7. The principal causes of that, the 4 contributions to that are the red bar, carbon intensity of energy, yellow, the energy intensity of the economy, essentially energy efficiency, and the pale blue population and the dark blue per capita income. And you can see that over the long term, as what you might expect, rising wealth and population have been the upward drivers, and improving energy efficiency and decarbonisation of the energy system have been the factors that have tended to reduce emissions. In the last decade, what we saw was the very rapid industrialisation in the BRIC countries, leading to per capita income growing more quickly in that decade. That was one of the principal drivers upwards. But perhaps most worryingly of all, what we saw was a reversal of the trend of decarbonisation of energy towards carbonisation. The energy system became more carbon intensive in that decade, principally as a result of use of coal in the most rapidly growing economies. So not a great picture, but when we look at mitigation, this is one of the important conclusions that Myles flagged from Working Group 3, limiting to warming can be done, but it involves substantial technological, economic and institutional challenges, very substantial, I would say. If you look at the baseline, a sort of business as usual projection of global carbon emissions, so this is global carbon emissions in gigatons per year out to 2100. In a business as usual world, that might grow from the current 50 to about 100, resulting in carbon dioxide equivalent concentrations of over 1,000 ppm, so way off anything Myles was talking about as an acceptable future. If we want to get down to 3 degrees or 2 degrees, those are the sort of pathways we need to go down with global emissions peaking relatively soon, or for 2 degrees very soon, and then falling to quite low levels by the end of the century. So a completely different pathway for the energy systems of the world. That means, as the conclusion here says, wide-scale application of best practice low greenhouse gas technologies in the energy sector. It means energy efficiency and low or practically zero carbon energy sources. And that can be done and would lead to substantial emissions reductions. It would mean a very significant upscaling of low carbon energy. Low carbon energy currently provides about 15% of the world's energy. The right hand, the colour coding is reasonably consistent. That's used from here on. Yellow is a 3 degree world and blue is a 2 degree world. So in a 3 degree world, low carbon energy needs to rise from 15% of global energy to about 40%, almost tripling by 2050. In a 2 degree world, that rise needs to be even more substantial, almost a quadrupling of the share of low carbon energy by 2050, and low carbon energy to be the overwhelming dominant source of energy by the end of the century. That can be done, could be done. It is technically possible, there's no doubt about that, but it will be a challenge. At the same time, this is not instead of, at the same time, energy demand will need to be reduced below business as usual trends through energy efficiency and behavioural change. We're looking, as the earlier charts showed, at energy efficiency in a business as usual world improving by about 1% per year. That would need to rise to nearer 2% to get to a 2 degree world. That doesn't sound a lot, but it's a doubling of the activity in energy efficiency, so it's pretty substantial. My own view is it's not as challenging as the low carbon energy change of trajectory, but it certainly isn't straightforward either. How much does this cost? Well, this is one of those classic IPCC rather nuanced statements. Mitigation costs vary, but do not strongly affect global GDP growth. This is where the colour coding breaks down, of course. So on the left-hand side, you've essentially got a 3 degree world, and on the right-hand side, a 2 degree world. The y-axis is the reduction in global consumption, the reduction in global economic activity as the result of mitigation. In a 2 degree world, that might be something like a 3% reduction in gross world product by 2050. In a 2 degree world, sorry, a 3% reduction. In a 3 degree world, perhaps only a 1% reduction. Those are, of course, significant amounts of consumption, but the not so prominently visible but very important numbers below that are also, I think, worth understanding. These changes are projected changes on global consumption that is perhaps doubling over this every 20 or 30 years. The implied change in the global economic growth rate is 0.03% to reach a 3 degree target, or 0.06% to reach a 2 degree target. So essentially lost in the noise of year-on-year changes in global economic output. The changes in economic activity might be small, but the changes in investment patterns are very big. Extraction of fossil fuels and building of power plants need significantly less investment, not surprisingly, than in a business as usual world. And investment in low carbon electricity generation in renewables, nuclear power and CCS needs a substantial increase, and investment in energy efficiency needs an even bigger increase. Just to put those numbers in perspective, total investment in the world energy sector is about 1,200 billion US dollars. So 1,200 on the scale, that's sort of double the change in investment needed in energy efficiency activity. So very significant shifts in investment, not surprisingly. Policy, the IPCC does cover the science of policy, and I'll say something about the difficulties of doing that, and identified which policies are being used. So policies are being used through direct provision of government services, through regulation, through economic instruments, through information programs. And along the horizontal axis, the scale of those programs. So some very option-specific programs, a standard for lighting, and some very economy-wide, a carbon tax. And that a range of policy instruments is being used. And the carefully coded statement at the top says sector-specific policies have been more widely used than economy-wide policies, which is sort of code for saying nobody's used carbon pricing very much so far. I'll say a little bit more about that. So that's the end of the official view. Some personal observations really to add to Myles. I think the key conclusions are robust of the Working Group 3 report. That's because they tend to be rather understated. They are rather lowest common denominator. So based on knowledge as it currently is, which is of course always worth saying, I think the key conclusions are robust. There is government, a government role in the summary for policymakers. Myles described it very well. Engagement or interference, depending which perspective you prefer. But there isn't government engagement in the main report. So if you're prepared to wade through all 1,400 pages, you will find what the people who wrote the report think. There is a predefined chapter structure, so I am only meant to know about climate mitigation in buildings, but that's actually a very unhelpful way to think about this whole problem. It militates against systems thinking, in my view. Another key problem is that this takes quite a long time and a lot of effort, and I'll show you in a minute an example of that, meaning that the data and the analysis is frankly out of date by the time it's published. The report actually came through the mail to me today. It's actually now physically been published as hard copy, but already the results are clearly out of date in some places. The other issue that Working Group 3 faces, which I think is different from Working Group 1, and I've discussed this with Myles, is that Working Group 1 has a body of science which all its authors tend to sign up to. I doubt if there are many Working Group 1 authors who think the laws of thermodynamics are wrong. But you would be hard-pressed to find any theory of the way that society and the economy works that all Working Group 3 authors sign up to. That is just the nature of social sciences. I think that within Working Group 3, some disciplines are more influential than others, economics, in particular economic modelling probably, and some of the conclusions reflect that. But my colleagues who worked on chapter 15, the chapter on policy, probably had the hardest time, because they are meant to describe the role of policy in a way that is not policy prescriptive. That's quite a challenge, actually, and is why the conclusions on policy are, well, frankly, anodyne. What are the implications for a climate agreement? I think there are three broad categories that I will quickly run through. The first is investment challenges. I think the timing of the investment challenge is critical. The investment needs to be, the changes are needed very quickly. This is the chart that I showed you earlier. You can see that global emissions need to peak in 2030 to reach 3 degrees perhaps. They need to be peaking about now to reach 2 degrees. And yet the energy system has lots of long-lived capital in it that we can't realistically change overnight. So reaching a 2 degrees, we need to start now, or perhaps even we should have started already more strongly than we already have done. It is quite a challenge. The other point I would draw attention to is the focus of investment and the sorts of technologies that are required to be invested in. Again, you've seen this, but with the official headline. My headline on it would be, the key investment change is broadly to change from very centralised investments like coal fields and oil fields and large power stations to decentralised investment, solar panels, energy efficiency in buildings, more efficient vehicles. I think that challenge has not really been set out as clearly as it should have been from the IPCC, because it's not just the scale of the investment, but the number of investments that need to be made is vastly larger than have traditionally been thought of in the energy sector. Just two points from the report that I think indicate the IPC is underestimating the scale of the decentralisation challenge. The first simply shows, and I asked you to look at the central column there, buildings. The bars I showed you before are from the integrated assessment models. When people actually look at the sector in detail with much more disaggregated models, they find the potential is actually quite different from in the integrated assessment models. So there is a question about whether the models we're using are quite up to the task in mitigation. The second point is the point I mentioned earlier about some of the data being out of date. The right-hand chart here, sorry, let me apologise for the busyness of these charts. It's a function of the Working Group 3 reporting mechanism that we seem to like very, very complex charts. The right-hand chart here shows that the costs of power generation using different energy technologies. Just look at the top one. The solar PV utility scale is judged to cost somewhere between $100 and $200 a megawatt hour. That's 10 to 20 cents per kilowatt hour. We know that in the Middle East now, new feed-in tariffs are being set at around 6 cents per kilowatt hour. That's data from the International Energy Agency as of last week. And that's simply because in the time since the data was put in peer-reviewed papers to be judged by the IPCC, to come out and be published, the price of solar panels has fallen very rapidly, as most of you will know. So whilst there was absolutely nothing wrong with the process, the outcome would have been fine if this is talking about 2010, it's not so useful for thinking about the future. I think that means that the scale of the energy system challenge has not been properly addressed by the IPCC. In crude terms, we have to move our energy system from one that is powered by stocks of fossil fuels, essentially solar energy accumulated over millions of years, to one based on flows of solar energy, whether that's solar itself or wind or other renewables. And that raises huge questions about intermittency. And we know in principle that those can be addressed by some combination of flexible generation, flexible demand, energy storage and grid interconnection. But what the best way is of doing that is not very well known. We know there are issues in countries that have high levels of renewable electricity, and they haven't. This remains an unsolved challenge for technology, for markets, and for public policy as well. So I'll just end with a word about a couple of the policy challenges. The first is the scale of the challenge. People tend to think about climate policy as being a global issue because climate is a global commons. But if we're to change the energy system through the policies that work, then it's not a problem that can be solved entirely at global level, or indeed even at nation-state level. City level, corporate level, community level, household level actions are all implied by these mitigation scenarios, and policy frameworks will need to enable action at all those levels, and I think that's a bigger challenge than has often been recognised. And the final point is really to challenge whether climate policy is the right way to think about the issue at all. sorry, let me just, this slide shows the point about, the need for thinking about climate policy at much smaller scales. If we think about the policies that have been effective, they tend to be things like performance standards for vehicles and appliances, things like feed-in tariffs, things that have been quite technologically specific rather than energy and carbon taxes. And so that does mean that thinking at those smaller and more granular scales is important. The final point is about whether climate policy is the right starting point for a discussion. If we're talking about policymakers changing energy systems, in my view, they're unlikely to do it solely for reasons of climate policy. Why do energy ministers lose jobs? Not because of climate policy, but because the lights go out. So energy security, access to energy, health impacts of energy are at least as influential as climate considerations in the energy policies of most countries. And we need to speak in ways that will be salient to policymakers. I'll just give you one example, which is from the IPCC report. The diagram shows where climate policy can help address air pollution. It doesn't do that directly, it does it by fuels, because fuel switching away from fossil fuels means that there are fewer emissions of air pollutants. And if you look at where there are very high problems of air pollutions, as expected, these are in the megacities of the developing world. We know it is likely to be far more influential to policymakers in those countries to show the impacts on air pollution than it is on carbon emissions. So why the question is, should we be talking to them about climate policy, or should we be talking to them about sustainable development and a wider set of policies? So those are just a few thoughts. As I say, there's nothing there that will provide provides much direct guidance for policymakers on what they ought to do in Paris, but I hope it provides some ideas about the different challenges and the different ways they might approach things. Thanks.
Am I on? Yes. We've got plenty of time for questions. What I'll do is, so that you don't both have to crowd around that microphone, I'll give you one of you this one.
Or
oh, have you got
that?
Oh, you've got your mics. Sorry about that. Okay.
Comments? Yes. Are we going to use a mic for?
I think I'm okay.
We're recording, so please wait for the mic. Thanks.
Thanks very much. What I'd like to do is offer a comment that might speak to a number of themes that you both referred to, either in the policy setting area or in the sort of informing the general public area. And it's made popular most recently by a book by Daniel Kahneman called Thinking Fast and Slow. But he's referring to the fact that cognitive science suggests that we have two systems of reasoning, a fast and efficient, fast and frugal system, system one, and a slow and deliberative system two. Science is the sort of paradigm case of system two reasoning, but humans in the cut and thrust of daily life hardly ever use system two. So there's a sort of a translation exercise that I think happens immediately when a scientist talks to a journalist or when a scientist talks to a policymaker. And so if we ignore the actual human sort of habit of actually operating in system one most of the time, we may continue to be frustrated by the fact that our system two deliverances don't see the light of day. So I wondered if you feel that that's an interesting way of engaging with the problems, and I'm interested to hear your comments.
I can start off on that one at least. Well, there's several ways people have responded to that problem. It's certainly a problem the community is very well aware of, the sort of boiling frog situation that, when are people ever going to take notice of something that's happening so slowly? And some people have reacted by saying that we really have to focus on the tipping points, the sort of potential urgency of the problem. I personally think that's been counterproductive. I think there was quite a lot of talk along those lines prior to the Copenhagen meeting in 2009. I think the IPCC, by and large, has been quite careful to steer clear of that. But there certainly has been plenty of sort of rhetoric, partially justified by the IPCC along those lines, to try and talk up the urgency of the problem, to get people thinking in System 1 terms about it. Perhaps more constructive. So I don't, as I say, that's one reaction to that problem which I don't think works. On a more constructive level, one of the things we're doing at the moment in Oxford is working with Climate Central, a climate communication operation in the US, on making quantitative the link between climate change and extreme weather, such that when weather events happen and people are kind of responding to them in their System 1 way of thinking, because when your house is flooded, you're very much in a System 1 mode. We are there to say how much, if at all, climate change may have contributed to the risk of that event occurring. That's something we can tell people, and it may be, this is, as it were, a gigantic experiment with public consciousness here. We don't know how this sort of information will play out. A lot of times, of course, we'll be saying climate change had no role in this event. But sometimes it probably will. And one of the interesting questions I've got is whether, as that link between climate change and extreme weather becomes more tangible, whether that has more impact on public attitudes to it. But, beyond that, all I can say is it's a problem. That's just the nature of this. It's the nature of this problem. But I think we just have to, communicate as best we can.
The first thing to say is that there's an opportunity there as well. It's actually it's in the field I've done most work in, which is energy efficiency. This distinction is relatively well known and accounts for the fact that the energy efficiency of the global economy is probably 10 to 20% lower than it ought to be in a System 2 world, because people, crudely speaking, people value the pound they've got over the pound they might save. And it's fairly well established over 30 years that there's always a 20% potential for cost-effective energy efficiency delivery. And of course, that doesn't mean that means there's an economic opportunity, and it's one of the arguments about the economic models that are used in the IPCC is whether they properly account for that, and I believe they don't. So it's not all bad news, actually. There's some positive factors. I think I would be quite cautious about applying findings from experimental psychology to public policy, because it's a collective action problem. So I think the more interesting question is about how different modes of thinking affect social engagement, affect the political process. And clearly they do. In this city we know that low carbon West Oxford, which has done a lot of work on carbon emissions reduction, was formed in a reaction to the 2007 floods. Now, that's completely irrational in a way, because there's nothing that a community in West Oxford can do that will significantly affect climate change on their own, but it was a very human reaction to that. So I think that linkage is quite important to think through, that and to capitalise on, that we mustn't say this is a global commons problem and therefore there's nothing you as an individual or a community can do about it.
Yes.
I haven't got the microphone.
Sorry, can people say who they are, and then Benita next? Yeah.
Hello, thank you very much. My name is Colin Hannaford. I'm not a very important person, but my son said to me recently, Dad, do you realise how often you annoy people? So I may be about to annoy some of the people in this room, but I'm going to take up your point about the people of West Oxford, who, generally speaking, I would guess, have little faith in God. But a huge proportion of people in the world do believe that God is caring for them. My question is therefore rather simple. Have you thought of engaging religious leaders in simply informing those people who believe in God that God isn't looking after them quite as much as they think He is? They think He is. That might help. That could help with your long-term thinking also, because people react both quickly, first, what did you say? First level, level 1, and level 2 on that, in that particular sphere. You don't need to comment, but I'd be interested if you can. Thank you.
I'm probably not the right person to do that job because I don't believe in God. But it is happening. I mean, many, not all, but some religious leaders have raised this as a moral issue, and I believe the Pope is planning an encyclical on climate change. Is that right?
Yep.
So I think that yes is the answer.
One of the most terrifying experiences of my life was presenting to the Papal Academy. You sit, it happens in a round room, and you know that previous occupants of the position you're standing in, it's worked out very badly for them. And you'll think, I better get this right. No, I think I've actually given quite a few presentations to churches. I think I've only engaged with Christian religious groups, but I would have no problem with engaging with others as well, because I think it is important that this is an intergenerational issue. It's and if any institution in the world is concerned with intergenerational timescales, it better be the churches. I mean, after all, who else is looking out for the unborn? They don't have a vote after all. It is one of our problems in a democracy is actually how we deal with problems which affect primarily people who can't vote today. So that's I think they do have a very very big role to play. Thank you. Benita. As the microphone's getting to him, I should just say Benita Muller is probably the person in Oxford who has been most engaged with the overall United Nations Framework Convention on Climate Change policy development process. And so what's your take on the IPCC?
I've had many a night, yes. I just recently joined the ECI, and I'm very glad to tell you this. But I have a suggestion about the depoliticization of the IPCC. I think, as you may have noticed, it gets really quite tricky when you start talking about countries or country groupings. That's the most delicate one, okay?
Yeah.
Now, some of these, even the World Bank with the high income, low income is delicate. BRIC, it was actually invented by some consultancy in the US, McKinsey or whatever. Hugely different countries, right? So my suggestion, why don't we look at lifestyles and the impact? Now that sounds very sort of airy-fairy, as opposed to saying poor people. How much, when you make these comparisons, is contributed by the global poor or by subsistence farmers type of thing? How much is contributed by the rich or some other definition of lifestyle? Because that takes away the country focus, and it gives us some ideas of where we may need to push changes in behavior, right? And I think that would be a way to get around the focus on countries, and they're always scared that they will be singled out unfairly. It's always the big scare. That's why you have these all-nighters in the IPCC. So that's my proposal. Thank you.
I agree, it hasn't been done, and at this level, and ought to be done, because those data I showed are about whole countries, and not about, and I think we know that the rise in emissions in China and in India is not due to Indian peasants, it's due to the rising middle class in those countries. Whether it will be less controversial, say, with the Americans to take a class analysis on climate change, I don't know. It sounds a bit Marxist to me, but it would be worth trying.
I was going to say
It
it sounded
amounts
like a
to
great
class,
idea.
Benito.
I was going to say it sounded like a great idea until you called it Marxist. But, okay, I hadn't thought of that. I mean, the distilling everything down into national discussions. I mean, it's particularly when you're talking about physical climate science, and you have Bolivia's view on the physical climate science. It is somewhat bizarre. I mean, I think that is a problem. As I said at the beginning, I actually became very disillusioned with the IPCC after IPCC after the sort of success of the 2007 assessment and winning the Nobel Prize and all that. I think maybe there's some bad luck associated with the Nobel Prize. Sort of bad stuff happens after you get it. But there was definitely a period in which it wasn't looking like such a useful institution, and I think the fact that it was so embedded in the sort of competition between nations was I think part of that. As I said, I've sort of come round to a grudging acceptance that it's the way it is, and we do run our world through the nation-state institution. And I take my hat off to you if you wish to move on from nation states, but you may have more things to deal with than climate change if you want to do that. I think that's the problem we have. It's not very satisfactory, but it's kind of where we're at. Would be my take on it. Maybe that's not sufficiently revolutionary for people in this room. But, woman here in the centre.
Thank you very much. My name is Michelle, and my question is, so my understanding that for climate change policy, there's the mitigation side and there's the adaptation side, and I was wondering if you could speak a little bit about the extent to which, policy, or like the extent to which there are interactions between the two types of policies, and whether there are strategies for choosing mitigation and adaptation to best benefit the system as a whole. Thank you.
You could probably lead on that one.
Well, to a very considerable extent, not completely, but to quite a large extent, they're separable. We need to do both, right? Viewing them as alternatives is not a very sensible approach. We are going to get significant warming. We should try and adapt to that and assist particularly people who have less capacity to adapt. To adapt, we should try to do that as effectively as we can, and at the same time, we should try to mitigate. In some areas, there are interactions, particularly in land use. It's a pity that Yadvinder Mali isn't here to talk about forests, because that would be that's probably the biggest area of interaction. But it's certainly a weakness of the IPCC that it has adaptation here and mitigation here, and so I know about mitigation, and so I'm not meant to know about adaptation, and that actually runs through the scientific community. I've sat down I've been in a building with the adaptation people upstairs and the mitigation people downstairs for a long time, and there isn't enough interaction, for sure.
I'm slightly surprised that was your reaction, actually, because certainly in buildings, you'd have thought the obvious adaptation measure, if it's getting a bit hotter in the summer, is stick on some air conditioning. It's exactly what you shouldn't do for mitigation. So I'd have thought certainly for sort of buildings policy, I mean, they're fairly intimately linked. And I think, as you say, it's a real problem in IPCC that these things are siloed up.
Yeah, I mean, buildings is probably the biggest area of interaction, but much of what you can do, notably insulating a building, which we in this country tend to think of as keeping the heat in, also keeps the heat out. So a lot of essentially passive design features run across mitigation and adaptation. That doesn't mean there's no areas of conflict. There are, and those need to be thought through. But generally speaking, the measures in buildings are synergistic.
Yes, did you? Yeah. The mic down here, please.
Thank you. You mentioned investment, and Rockefeller have pulled out, I believe, of their trillions from fossil fuel. There's a conference in Oxford in the last 2 days of this month entitled The Cost of Life on Earth, Companies, Climate Change and Your Money. And the whole purpose is investment. And you said it had to change, I think, from centralized to decentralized. Can you help those who are in the churches and mosques, as well as the trade unions and many other places now, desperately trying to see how they can disinvest, but what do they put their money into? What are the renewables or whatever that we ought to be putting our money into?
I mean, I can give a scientific answer. I'm not a financier, so I'm not the right person to ask about the correct financial instruments. I did actually send, as soon as I heard of the disinvestment campaign, I sent that diagram I showed to one of the people involved in it. So you can probably guess which side I'm on from that. So it's very, I mean, as I said, it's pretty clear what we need to invest less in and what we need to invest more in. I think it's not a trivial issue. We will continue to need fossil fuels for the next couple of decades, and that will require some investment in them. We will need gas-fired power stations to back up a renewable system, for example. So these are not simplistic issues, but the overall direction is very clear. Have government and the finance sector stepped up to the plate to organise enough appropriate instruments for doing it? No, they're probably relying, I mean, at the moment, how do I do it? I put my money into small community projects that do this sort of thing, as probably some other people in this room do. Is that sufficient? No, it's not.
So I've got, as many people in this room know, I've got quite strong views on this one. I think the disinvestment campaign is missing a trick in not presenting a clear set of what they want the fossil fuel industry to do. And I think that's, I raised this with Bill McKibben at a recent Chatham House meeting, and I think his response could fairly be categorized as a bit like Jeremy Irons in Die Hard with a Vengeance. I want you to die, you know, and you know, that's not a constructive thing to say to a company. If you haven't seen Die Hard, no, this dates me, doesn't it? I saw it when it first came out. Anyway, probably before climate change was an issue. Interesting that. Anyway, you know, I think we do need to think about what a, you know, if you've got a pure extractive fossil fuel company, that's what they do. 99% of their profits are made of digging this stuff out of the ground, and you're a shareholder in that company. You want to put up a shareholder motion. What should your shareholder motion say? And it's not reasonable to ask a company to shut itself down or take itself out of business. Nor, we've discovered, is it effective to ask a company whose business is centralized fossil extraction to do the kind of decentralized stuff. I mean, BP tried it rather half-heartedly and made a bit of a hash of it, I think. Yeah. To do the kind of decentralized stuff that Nick is pointing towards. So I think the disinvestment campaign is missing a trick. I made a suggestion to the Cowley Synod Disinvestment Committee. Just to get, you know, I do engage with churches here. It went nowhere. But if you look at the scenarios where we actually do meet 2 degrees. By the way, I'm giving a lecture on this in a few weeks' time on CCS policy following Paris. If you look at this in the build-up to Paris, if you look at the scenarios in which we do meet the 2-degree goal, we're burying 10% of the fossil carbon we dig up by 2030, and we're burying 100% of the fossil carbon we dig up by the time temperatures reach 2 degrees later on in the century. So what I'd like the disinvestment campaign to start doing is asking fossil fuel companies, show us your strategy for getting to 100% sequestration by the time global temperatures reach 2 degrees. And if the disinvestment campaign would do that, rather than just blowing raspberries, then I think we might have a slightly more constructive outcome.
I'm not disinvestment campaign.
No, I know, but I suspect there might be people in this room who are engaged with this, and I think that the disinvestment campaign need to stop and think about what do we want the fossil fuel industry to do. If Shell were to turn around and say, here we are, these are the fossil fuel plants we're going to convert to sequestration over the next decade and a half. We're going to be at 10% sequestration by 2030. We're going to be at 100%. We'll be increasing at 2% per year at that point. We're going to be at 100% sequestration by the time temperatures reach 2 degrees. I would say more power to them. Well done. Thank you for solving the climate problem. And here's my money, because I think you're a good company.
Just for the record, I don't entirely agree with Myles on this, because we've
Some of you may recall we had debates on this.
Interesting debates about it. And actually, largely because the companies who do the extraction are not the same people who do the burning. There's that separation too. So, I mean, we need to be clear who we're asking what, because you might have, I think there are different implications for Shell, BP and the coal extractors from the implications for, say, utility companies who can reasonably be expected to stop investing in coal-fired power stations and start investing in wind turbines and solar panels, and to some extent are doing.
Yeah, so I think investment in the power sector is a different sector. There you can talk about decarbonisation, but when you're talking about investment in fossil fuel extractive companies, there's got to be a different strategy. And I don't see how CCS can't be most of it, but there we are. You'll get a rerun of another debate. Sorry, Chris.
The discussions about mitigation and reaction to climate change are usually framed in terms of costs and impacts that are detrimental to our way of life.
Yeah.
And I'm just wondering whether, in terms of talking about sustainability as the policy framework rather than just climate change, that one could frame the discussion in terms of ones of huge profits that are there to be made by companies that actually react in an imaginative way. For example, companies burying their carbon and squirting it into the ground. So I want to ask, within the IPCC and the economic assessments, has there been a discussion about the potential benefits to society and our economy, and that countries that actually react faster rather than slower have the potential to greatly enhance their way of life in many ways?
Yeah, there's quite a big literature on double dividend, as it's called. It goes into macroeconomics, and suffice to say some of the model results that I showed would not be entirely agreed with by every economic modeler. It works at all scales. If anybody who's interested, I can point you at a report I was involved with last year called the Oxfordshire Low Carbon Economy Report, where we precisely took that view. We took the view that we were talking to economic and policymakers in Oxfordshire who would think they have no role in the global climate process, but might be quite interested in what the economic opportunities are in a knowledge economy for low carbon technology and low carbon services. So yeah, there is a growing literature in that, and that tends to get aggregated away when you see the sort of total effects and, you know, what does 1% of gross world production mean? Well, it actually means a few people get worse off and a few people get better off. I mean, it's, you know, aggregating it is not the whole story.
And I think it's, again, an Oxford context on this is that my understanding as a non-economist is that these general equilibrium models that typically the IPCC has relied on to date tend to understate those potential benefits. Yeah. And one of the things Dwayne Farmer and colleagues in INET are working on are these new agent-based approaches to economic modelling which allow that kind of behaviour to emerge rather better, and so hopefully in future assessments will be better represented. Yes?
Yes, it's really about the basic conception of the IPCC. And it sounds like it started off being classic science being truth to power. And science will find the facts through this very wonderful process and then tell the policymakers what should be happening as modified by probability distributions and whatever. And clearly it runs a lot of trouble. I'm just wondering whether somebody said, well, let's go away and think whether this truth to power model is really the best one to carry on with indefinitely. Whether something a bit more flexible, imaginative, open-ended, rambunctious would actually help.
I mean, I certainly feel that the IPCC is serving, I mean, there's no question it has served a useful role, and as I say, I've come grudgingly to believe it is still serving a useful role. If you'd asked me that question 2 years ago, I'd have said, nah, they should shut it. But if we were designing this from scratch, I don't think we'd be where we are. And it is a big worry, this problem of this idea that you can have that you can ever have, and you should even seek universal consensus that's presented to policymakers as, all scientists agree this, and then and because science, as everybody knows, doesn't work that way. There's always scientists who disagree, and that's part of the growth of scientific knowledge. So I think but I think those sorts of problems, as you say, the IPCC has come into problem. Those sorts of problems can best be corrected by being clearer to people about what the IPCC can do and what it can't do. That it can't present the truth. Then rather than, I think we are where we are. Governments rather like this institution for better or for worse. They're going to carry on with it. And so I think the best we can do is work out how to make clear to people what its limitations are, so that they don't have unrealistic expectations of it in the future.
Yeah, I mean, it's worth remembering the history of it is an intergovernmental panel. It is not a panel of independent scientists. It has been set up to be to have explicitly these interactions with government. And in a way, I think that's both its strength and its weakness. So I would say we probably need the IPCC, but we also need some more fleet of foot, more campaigning, more imaginative institutions as well.
I mean, one specific thing is I certainly think the increasing tendency of the IPCC to actually get involved in quite detailed assessment of individual sectors of the economy and detailed impact assessments of impacts in specific regions of the world. I think I've compared it publicly to using the 101st Airborne to build schools in Afghanistan. The schools get built, but if anything goes wrong, it's an absolute disaster, and it's also a very expensive way of doing it. So I think if we should, I wish the IPCC could agree on some kind of principle of subsidiarity, that we don't do things using an intergovernmental panel that could be done much more effectively, much more flexibly, much more up to date by national level assessments and so on. The problem with this, of course, is that a lot of developing countries, after all, the process is owned by the world's governments, who are, of course, dominated by developing country governments. A lot of those governments would hate this suggestion because it was just they would get shortchanged and we'd have all the, But I think the solution to that is to make sure that we fund national level assessments properly in developing countries rather than trying to do everything at an intergovernmental level.
Sorry, I hope this one's on. Good. Before we thank Nick and Myles, I think it's been a brilliant seminar. I just want to tell you about a couple of up-and-coming events. For those of you who've been coming every week, forgive me because I say it every week. On Saturday, there's a fantastic event being organised by our undergraduate group, 21CC. It's a day of debates on really good nitty-gritty global challenges, and it's over at the Maths Institute. There are still some tickets left. Next Wednesday, we have Gary Kasparov talking over at the exam schools. Get in there quickly for that one because that's filling up. And then on the 2nd of March, we're very privileged to have Dame Sally Davies, Chief Medical Officer for England and Wales, coming to talk about antibiotic resistance. Just to let you know, due to demand, we have just changed the location for that today. It's going to be in the exam schools. So if you were on the waiting list and feeling frustrated, it's fine. You'll all be able to come now, so do sign up for that. And obviously, please do keep coming to the Thursday seminars. I think the debates are proving very lively. It's great to have so many good questions from the floor. So would you all join me in thanking our speakers today? Thank you.